only Dev Alliance meetup. Thrilled tonight to have Clare Corthell coming to us from Seldovia, right? Clare normally lives in San Francisco, but she actually grew up here in Alaska in the Kenai Peninsula. So welcome back home. Clare studied computer science and product development at Stanford, and is a data scientist, currently the product manager for, is it map data and visualization? Do I have that right?
Visualization and map data, yep.
Okay. So really excited to hear all about those products and history of mapping tonight. Take it away, Clare.
Great. Can you see my screen?
Yep, we can.
All right. Great. So thanks everyone for joining. I know this will be a little bit of a potentially different type of talk from what you see during Dev Alliance. As I understand it, you typically have very technical talks. This one is going to be about mapping as an industry and places where I've touched mapping throughout my career and things that I think we can bring back to the state and our ecosystem. And I would love to discuss with this group. So I'll do my best to get through the 53 slides that I have and get to the interesting part, which is the discussion with all of you. So feel free to ask me anything. I'll let you know if I don't have the answers and there's other experts that I can defer to, but would love to hear all of your questions throughout this. If you want to register those in the chat as we're going, feel free to do that. I won't address them until the end, but I can address those in order there. Great. So talking about mapping products or map products in general is great because people intuitively.
We have your desktop up, but we don't have the slides. So.
Oh, interesting.
Oh, there we go.
I'm kind of like, I'm remote driving these. Is this working?
Yep. Yeah, we got.
See the phones? Cool. All right. So you've all seen this, like people know what maps are. They use them quite frequently. And I'd be curious if anyone wants to chime in right here. Let's play a little guessing game. How much would someone have to pay you to give up the map products that you use on your phone? What kind of payment would you receive per year? Just throw out numbers. Like, I'll take a check and stop using Google Maps.
$400.
$500.
Okay.
It's funny. I think about the service,
pandemic,
like,
or not during a pandemic.
Good question.
Like as a subscription service, I would be hard to more than like $10 a month.
Yeah, all great numbers. Okay, I love this. So there was a study done, and it turns out that we found that about consumers would pay about $3,648. My slides are still advancing, right? Can you see this?
No, I see we're stuck on mapping here, mapping from the middle to the edge.
Oh man, this is not working then.
Okay.
Can you see it now?
Yep, they're advancing now.
Okay. So consumers would have to be paid about $3,500 to give up map apps, which is a pretty big number when you consider these little apps that you have on your phone, and then you might start to think about how frequently you use them and how much value they actually present to you. And this isn't necessarily the number that consumers actually pay in terms of like the ads that are sold against them or subscriptions or anything that they pay to actually fund these apps being built, but this is what you would have to be paid to give this up. So it's a slightly different number, but just to compare to other apps that you may have on your phone, LinkedIn, the annual revenue per user is like, it's something like $140. So it's actually quite low compared to these products. They're really valuable. So I want to talk through a couple different case studies today, but the takeaways I'd like to bring home today are that maps are really complex and really interesting. And they're the key to solving some of these really big problems. We may not notice that every day when we look at the apps we use on our phones, or the ways that mapping underlies all of the products that we use, things like Lyft. And we need to design products that work for these different ecosystems and maps that work for these different ecosystems, instead of trying to disrupt and rebuild things. And part of the reason for that is how expensive mapping is. And there's a lot of opportunity here to do that. And I think Alaska could be one of the places where that happens. And there's a couple reasons why I think that is. So a little background on myself. I'm born and raised in Alaska, but I went to California, and hopefully I'm back for good. But I studied design at Stanford, did a lot of engineering while I was there, and got a job as an engineer after that. But data science was this kind of budding thing that was happening around that time. And I ended up writing a curriculum for data science, and then becoming a data scientist myself, and working in a couple companies doing that. And as that ecosystem was growing, I started getting more into data science consulting, worked with a couple consultancies in that capacity, and moved into the product management role, which is really about owning the goals more than owning the solutions, and really figuring out how we can use data to improve the experiences of the users that we're selling products to and we're supporting. So a couple of those companies were focused on kind of like telcos. Thinking Machines is a data science consultancy that works with NGOs and international organizations that do things like poverty mapping with satellite imagery. Clover is an insurance company that works primarily on the East Coast and is focused on chronic health management and things like that. And Lyft, of course, is a ride-sharing product, as you know. So how we map the world is really crucial. And just to bring this home, in the 19th century, this is a good case study that you may know from the great exhibit that was shown in the Anchorage Museum last year. But in the 19th century, there were incomplete maps of the Northern Archipelago, and this led hundreds of British sailors and just massive amounts of funding to these dead ends in search of the Northwest Passage. And many people died in rather gruesome ways from those events, as you know. Other things that have happened: people drive into bodies of water, they drive down one-way streets. Things that depend on accurate map data can take quite perilous turns. Antarctica recently, in the last 2 years, was finally topographically mapped to a higher degree of precision than it had been previously. I think the error bars on this were like hundreds of feet, and now it's less than a meter. But the new satellite deployment from NASA in 2017, 2018 enabled researchers to actually construct an accurate map of Antarctica. So we know things like, when all of this ice melts, what does that mean for the salinity of the oceans? What does that mean for the Gulf Stream, the jet stream, like all of these systems that depend on the big air conditioner that Antarctica is, and that the northern Arctic ice cap are for the planet, things like that. So maps are basically two things. They're data and they're design. They serve some purpose with these things in combination, and they're the oldest data visualization in existence. So they use symbolic representation that's become really commonly understood. Things that depict land and seas and rivers, things that we all commonly understand, and show that in some sort of spatial representation. And this is OpenStreetMap. This is a 15-year-old open source mapping project that's basically the Wikipedia of mapping. It's a global project, has about 2 million active editors and something like 10 million users worldwide. And in mapping, we refer to two different kind of categories of data. One is static and one is dynamic. at least in the kind of new world stack, if you will, and we work in kind of modern web stack ecosystems with, airflow driven data flows and things like that, not the ArcGIS world that some of the folks here, working with municipalities or the state or things like that may be more familiar with. But the static data that we work with at Lyft in particular comes from OpenStreetMap, or at least a lot of it does. This is things like, the roads, places of interest, rivers, parks, whatever. Dynamic data would be things like traffic or weather, anything that changes or is more synthetic, more, directly observable, or less directly observable rather. And maps are design. So design is important and the crucial kind of second piece of this equation, because it helps us actually use the product. For example, what you see here are the topological and topographical maps of the London Underground. The topological map is designed to help riders of the Underground actually navigate and make station transfers, rather than to compare distances or to place things geographically on the map. Whereas the one in the foreground is a geographical representation, a topographical representation that's true to both of those systems, but is clearly potentially more confusing if you actually want to use it to make a transfer at a specific station. So things are designed with the use case in mind, and it takes a certain form. And every map is some interpretation of that data. It takes a particular lens and applies it. And that data is in turn a representation of reality that we've digested through some data model or way that we agree to represent that data. So as they say, the map is not the territory. These interpretations will influence how we see the world, because we do things like unconsciously equate size with power and color with heat and scale with distance and things like that, or space with distance. And I have a link here if you want to go track this down, but you may be familiar with this little demo they did in the West Wing of how map projections can change how you perceive the influence of various nations of the world, for example. And just to illustrate all of the different ways that we can take the globe, which is not obviously not flat, at least most of us believe it's not flat, and turn it into some sort of representation that's usable in a 2D space. There are many different ways to do that, and you might do that based on your usage, but don't take it as a direct fact. So maps are the product, and mapping is how the maps are actually made. This takes a lot of ingredients, and they're famously expensive as products. So Uber has spent about $500 million or more in the last 6 years building their maps. And they've used many different platforms to do so, including platforms that have plug and play map data. They didn't even build map data, but now they are building more. Apple and Google subsidize their own maps to the tune of billions. And these machines have incredible numbers of operators and map editors and people who are moving and changing things all the time. They're very big platforms. And as you saw before, the value to the user is also very big, but the equation of how you actually fund these things is not quite sorted out, as you can tell in the case of Apple and Google, who generally provide this as a part of their platform as an unpaid product. So this leads to a lot of questions when you look at how expansive this platform is. How do you get this data? How do you represent it? How do you process it? How often do you process it? How often do you ship it? How do you visualize the data? How do you interpret it? Are you interpreting it correctly for your use case? Are you visualizing it in some way that's understandable for your users? Is there a better way? And ultimately, how does this map actually help your users make their own decisions? Things like navigating the world, like turn right at this intersection and not turning right into, a river. So I'm going to walk through 3 different products from my career and talk about how the mapping technology is the backbone of those different products. First of all, mapping informal settlements. So let's start at the beginning of my career. We actually founded this company while I was still in college at the design school at Stanford. And we were trying to help people navigate to markets in the early morning, which was a challenging thing to do because it could be dangerous to travel before sunrise. We were designing this for dumb phones. So this is basically like Lyft, but on dumb phones and somewhat scheduled. So as you can see here, the product is generally a user who is interested in taking a route from one of these places to another place that's on that route, or potentially transferring, but probably not. They text to a short code and they send a message about the route that they want info on, and it sends them a timetable back. So it's kind of like a live updating bus. This was pre-shared, pre-express, if you're familiar with ride-sharing products that group multiple riders together, but these would pick up multiple people along the way. So you could choose to join the next one that was coming on the route, and this schedule would tell you how to do that. And what was interesting about working in this context, we were working with a couple NGOs in a neighborhood of Nairobi called Mathare. It's a smaller informal settlement than Kibera, if you're familiar with that area. Kibera is about 1 million people, I think, and this area was anywhere between 30,000 to 300,000 people. We actually didn't know how many people lived there. So we ended up doing a lot of work because, as you can see, this map is not super detailed. OpenStreetMap was not super detailed at the time either. So we ended up doing a lot of mapping of where people actually are, where they want to go. So more like user research stuff, and mapping of just like places of interest. So like these waypoints you see on the map were not well mapped and not understood. And so we ended up having to do a lot of the data surveying and the user surveying ourselves. And there's a couple takeaways here. I could probably give a longer kind of detailed talk on what it was like to run this project. It was quite an experience, to say the least. But we did learn a couple key things that really helped me orient myself in the mapping world. OpenStreetMap at the time in 2011 was not complete. And we really cared about things like, where are the street lamps? Where is it well lit? Because we actually wanted our users to be able to navigate via those streets. Like we needed them to travel on those paths. And so setting our own routes was a problem at the time. The second issue was that if you don't have a map that's relatively complete with all the roads, it's actually really hard to figure out where your users are, because in the process of taking that GPS trace, which is not very specific, and our users who had dumb phones didn't have GPS traces, but our drivers did. We couldn't locate the driver if we didn't have roads to snap to. We just didn't really know where they were. We could tell they were in the neighborhood, but we didn't know whether they were at the next stop and they were like on schedule, or we needed to amend the schedule. And the third, we had the wrong partners. We ended up, to put it plainly, we ended up being a pawn in the middle of a couple of different parties trying to use like transportation as a means for pushing each other around, basically. And I think what we learned from this is that the map is really important, and the use case can have unintended consequences or can be really valuable, because transportation does change the economics of an area and how people can get to market, literally in this case. So ultimately we said, hey, we can't like continue building this product. We spent 18 months on this. We're going to publish some papers and like try to hand this off. There's some great companies that are actually building much better products in this space now, but we can't spend all of our time here, because we would have to build the map, and we would also have to do extensive research on our customer to understand what they're actually doing and what they need. And we just don't have enough information. So good experience, dead product. So a product that is not dead, mapping urban roads with Lyft. So Lyft, as you know, is a ride-sharing company. I've been a product manager on the mapping team for a couple of years there. My team is about 200 people. The mapping team is about 200 people. Half are in the US, split between SF, Seattle, New York, and the other half is in Belarus, or it was in January. And my team manages the map data stack that we use internally, map visualization tools that we use internally, and the quality of the data. So we have about 8 engineers, 4 data scientists, 4 engineering managers, and a map editor team of about 20, I think, at this point. And we have other teams that do things like run ground truth fleets that collect high precision location data and imagery and things like that, and help us actually make this a reality. But Lyft ultimately is a transportation company, so we care about how the map reflects how people can move from point A to point B, either with their feet, with a scooter, car, as a driver, as a rider, maybe in an autonomous vehicle as well. We also have transit, which is pretty cool. This is OpenStreetMap over time, which again is a thing that we use at Lyft as well. And what you see here is that OpenStreetMap has gotten much better since 2011 when we were trying to use it in Nairobi. In fact, it's almost 100% complete and accurate. It's never possible to get to 100% because things are always changing and the data is always wrong in some way, or the schema is not quite expansive enough to capture every single case, but it's pretty close. And this is important to us because OSM is free and openly maintained, so that lowers the barrier for our company and many other companies to building mapping platforms. So maybe it's not going to cost us several $billions the way it did Apple and Google. One of the keys to this is that the Lyft fleet is actually one big sensor network. So people take Lyfts all the time, and the driver's phone is telling us where they are, which enables us to run the service and keep it safe and do all of the necessary bookkeeping to run the marketplace. But when you aggregate all this data together, it actually starts to tell you really interesting stuff. So what you see here is actually 1 day of trace data from the fleet aggregated. And you can probably recognize what it is. It actually looks like the road network, and it looks almost exactly like the map. And this gets really interesting when we take these traces and we overlay them on the map, because it starts to tell you where they're different. So you just take this diff and you look at what streets are drivable and look like they're being driven in the correct direction, and what streets are missing. So, and then we can actually go fix it, because it's this open source map. We can go back, fix this map, and everyone else benefits from it as well. So this is a visualization of a case in Minneapolis where we just didn't have the parking lot of this really popular cidery, I guess. There you go. Maybe I can get my new cider there. So we see these cases all the time, and for the most part, they're actually infill. Like all of the roads in the US seem to be pretty good. And we're gonna come out with some more papers about this soon. But the infill is primarily service roads, like service access to loading zones and garages and things like that, and parking lots. So it's pretty good. In terms of how we use this technology, it's also publicly published, and you can look this up on the Lyft blog if you want to dig into this. Our scientists did a great job of really discursively covering this, but we use a combination of Kalman filters and hidden Markov models on these like raw GPS and map match GPS traces to figure out when the car is on the route that we think they're on and when they're not. And then we take what is visualized here as green and aggregate that together. And we basically pop out all of the places that we think the map is wrong. And then we go fix them. So the key takeaways from this product have been that OpenStreetMap actually significantly lowers the cost and interoperability barrier for us to build our mapping platform. And it's surprisingly, it's kind of this dark horse secret. A lot of people don't know about it, but it runs a lot of companies' maps, or it is the backbone of a lot of companies' maps. One of the biggest ones is actually Facebook. So anything that you see in Instagram or on Facebook, any like Slippy map that you see is built with OpenStreetMaps. They're very competitive with Google, so they don't use Google products. Uber uses OpenStreetMap in various markets. Grab uses it in a lot of markets as well. Some other ride-sharing companies are kind of dual stack like Lyft is. So Lyft right now has a mixture of Google and OpenStreetMap. OpenStreetMap is primarily on the back end, and that's true of other companies as well. But it's starting to kind of come apart, and OpenStreetMap is starting to really shine here. The fleet is a really great sensor network, and I think this is true of a lot of fleets. You see this with like shipping fleets and things like that as well. There's a lot of interesting data coming off of those and interesting strategies that are coming of that. But for us, as the team that manages map data, we care about how it enables us to test the map. And it'll help us pinpoint where it's actually broken. And I want to segue into something that's a little closer to home here. So in 2018, I teamed up with K2 that was operating at the time on mapping Arctic ice. So this is Kotzebue. Some of you may be familiar. Shout out if you're calling in from Kotzebue. It was actually my first time in town, but we piloted a process for mapping sea ice because it was a really good environment for that. One of those reasons was because they have an ice road most years or some years. This is their ice road in 2018. It's a seasonal ephemeral highway, and sometimes they last for about a week or a month, and they cost about $50,000 to build. So people, are traveling from various villages up the Kobuk or along the coast of Alaska and moving things around, getting supplies, logging, things like that, moving machinery to Red Dog Mine. There's like all kinds of stuff that goes up there. And so this road can be really important. It's like this highway that pops up and goes away. But the ice has become less reliable over time. And so whether the ice is safe to travel on by foot or by vehicle is determined by thickness, ambient air temperature, ambient water temperature, a lot of factors. I'm not an expert in this, but thickness is one of the most crucial things to know, and that's really tough to measure. So we started looking at that as an interesting kind of metric for the integrity of the ice. And just to pull out a couple quotes here on what this meant to people locally, which I think is a really crucial thing for us to focus on in Alaska. I think we have a really strong kind of communal focus, and we're able to bring back a lot of the community insight on what's actually going on. A lot of the things we found as we were doing this work, someone had told us before we found it. And I think a lot of science and kind of tech development that happens here is like that. We just found that people knew where the ice was not as reliable, and then you check it with the data and you'd say, yeah, it actually is where it's less reliable. And it does seem to be melting on the underside. And, people don't, there's kind of user stories in here too. It's not practical to stop and check the ice because you have to, bore it out. Like there's no other simple way to measure the thickness of the ice. So there were a lot of really interesting stories and really tough stories that were coming out of kind of the user research side of this. And as you may know, the sea ice in the Arctic is disappearing. This is more of a PSA for people outside the state, but the Arctic is warming twice as fast as the rest of the planet, which matters quite a lot in the context of something that you thought was reliable last year and is now trending like this red line to be much less reliable this year. The ice extent, I think, was the all-time low in 2018, and we actually had to bump up our travel for the pilot at the time. I think it was like March 10th or something like that, because the ice was starting to go out. So we actually didn't necessarily know whether it was safe for us to be on the ice by the time we'd get there, things like that. We talked to some really interesting climatologists along the way, and this starts to point at the data problem here. Rick Tommen was super helpful. You may have seen him on Twitter. We have reasonable resolution from satellites, great. But the question remains, what is the quality of the ice? Is it stable? Is it rafting? All of this stuff is hard to see from space. So some of the things that were pointed out to us here was that we can do a lot of remote sensing of sea ice, but we can't really tell what the integrity is. So when you think about data and whether it's applicable to your use case, there was a gap here. We needed more information about whether people who were traveling on the ice would actually be impacted, as opposed to kind of the science question, which we illuminate here, which is how much ice is there? It's a slightly different question. This data isn't as useful to us. So our goal was, can we map safer routes over sea ice? Is there some way that we can just look at that narrowly focused goal? The hypothesis going into this was that it's possible to map ice safety metrics of some kind and to kind of pull those from the literature, and to do so with survey data, so collected data from sensors that we mounted on UAVs. Aspirational. The best part of this, of course, was going out in the field. I love going out in the field. So this is me doing some radar based measurement with our little like Raspberry Pi contraption in the foreground here, and the drone pilot and our assistant in the background. So the first method we used, just to talk about the technology here, was an ice thickness radar that I used this Novelda sensor for. It was an interesting trial. I don't think it's the right sensor for the job, but that's how trials go. It was a really interesting exercise because the sensor was only $400, and similar technology cost about $20,000 in 2010. So it was very easy for us to take this out and test it, right? Not a huge dent in the pocket. And drones similarly are less expensive than they used to be, much more accessible. And it was a lot easier for us to do things like, look at the road that was being used and see if we could see any visual distortion in the ice or visual markers for problems with integrity or rafting or anything like that. So just to bring this back to the question, can cheap remote sensors enable climate change resilience? Which is the kind of overarching aspirational question that I'd layer on top of this project. I think there's a bigger world that we can imagine that is enabled by the ubiquity and the cheapness of sensors that includes us being able to respond to these real-time changes. And if our environment is changing faster at the poles than it is at the equator, then we need to be asking this question now. We need to be asking this question sooner than our counterparts in San Francisco or other places might be asking this. And just to put this into perspective, if you take that sensor that I mentioned, the drones and everything else, the pilot cost for this, for mapping this road and figuring out whether these sensors worked, was a little bit under $1,000. And I'm pretty sure that included travel for all of the pilots and myself. The cost compared to 2010 is 6.3%, which is, it's almost a hard thing to sell because it's so cheap. And what you start to see when you look at how we can solve these problems is that Moore's law has actually taken effect on the distributed sensor networks that we've been talking about for years. And that is actually happening. And maybe it's also happening at the edge. Just to put a finer point on this, what happens in the Arctic doesn't stay in the Arctic. The types of things that we have to think about and address in Alaska, in the Arctic, in the Antarctic, are things that are going to become important elsewhere on the planet. We're ahead of the timeline in a way, and if we're not learning now, then the rest of the world will have to learn even faster as this thing speeds up when we're talking about climate and climate science. So how can we do that now? How can we take this action and start those learning cycles and get there faster? Just to draw this out in a chart, Project Drawdown is a program and now a foundation that a professor put together with a number of scientists to illustrate how, given the baseline of our CO2 growth in the atmosphere, how we might apply different combinations of strategies in order to bring that baseline down to something that would allow us to reach carbon neutral. So what you see here are moments of drawdown, which are roughly equivalent to that carbon neutral point. These scenarios include a number of different strategies that have been combined together to enable this to happen. And these are the trajectories that we need to be on, basically. So how do we get off this exponential curve? How do we take these technologies and apply them in a way that enables us to react to the ecosystem that we're in, to more efficiently operate, to serve users better, to do all these things? You know, ride sharing is putting 2 people in a car and saving 1 car of gasoline. How do we do more of all of those things and take all of those strategies and add them up to get to these moments of drawdown so that we can, you know, decide what comes next instead of worry about the wall that we're going to hit here. I have to turn this over to Buckminster Fuller at this point because I think he's the right character to really underscore this. I believe this quote is from the 60s, but Buckminster Fuller is a kind of designer, inventor, entrepreneur, you know, everything person who started thinking about the climate change crisis at that point in time and thinking through what we had to do to take steps to avert it. And he talks a lot about design science as a revolution and a way to collaboratively get out of this crisis. And what I think is really interesting about this is that it also averts the disruption that we like to talk about in technology, which is an anti-pattern for collaborating and getting things done, and probably not the most effective way to get us to things like the drawdown outcome. So how do we get to that design science, and how do we get to a place of design instead of disruption? Just to bring this back to maps, he had a really interesting contribution, which was a particular projection, a particular visualization of a map that still preserved the continuity of human migration, as he called it, with some lesser distortion of the planet. So the projection that was on your wall in a kindergarten in every classroom is very different from this. The size of the continents relative to one another are very, very different. And this, as a tool, was intended to preserve more of that relative size while also preserving the continuity of North America being next to Asia in this particular way, and South America being next to North America, and preserving how we actually saw humanity grow out from Central Asia, right? So this is very aspirational yet very applicable kind of version or playing out of the design that he's talking about. So if we take all of these observations together, that I've kind of painted across these different examples, what we've seen is that mapping is at a convergence point of a couple key things. There's Moore's law, which is this cheap kind of accessibility of technology that enables us to collect data at scale, collect it over much larger spaces, more frequently, more synchronously, in all these different ways, and enables us to do more and to actually get data about the world. The second is that we have the infrastructure to actually bring that data back. We're starting to see satellite networks that will be able to connect to your iPhone, and suddenly you'll have cell connection everywhere in the world that you can see a satellite, things like that. And getting data back from a place like Kotzebue, for example, entailed like hand carrying an SSD on the airplane or sending it via courier, which was cheaper than putting it on the internet backbone that we have there. And that's the third thing that's really enabling this to converge is open source. And I wasn't totally convinced with OpenStreetMaps because of my experience in 2011, but it turns out if you get millions of people to work on things iteratively over time, and they deliberate and they work through their disagreements and they create new ways to solve problems collaboratively, you create a lot of value if you are able to sustain that over time. And so what we're seeing is like this base map literally is now able to support much more. There's all kinds of things we could build on top of that. What if we built all of our research on top of this open source map so that research was all indexed to the same map? What if the context of that map was common between them so that you could federate data sets and start to do meta-analysis and all this other research? What would that actually look like if you can contextualize everything in the same universe of data? There's this really kind of interesting build it and they will come. We don't know, like you put all these things together and you don't know what will happen, right? What does that actually look like? The second piece is the software piece. We don't rely on ArcGIS, as I mentioned, and other proprietary GIS software at Lyft and at previous companies that I've worked at either. And I think part of that is because that kind of garden wall is starting to break down because the software that's necessary to project data and translate between projections, or to store it in a geodatabase or represent it in wickets or whatever it is much easier to access now. And there's packages in Python and bindings in C and all this stuff that you can use. And we have visualization software and all these other things. So we can take all of this and think about where this is leading us. Like what kind of big problems such as climate change can we address with these tools and with the design science, or taking these problems as a problem of data and design together. What problems should we solve? So demand is a really interesting thing in mapping because it defines what maps are actually produced. This makes a lot of sense if you think about it, because a lot of people go to New York, for example. So Google spends a lot of time making sure that all the restaurants in New York are correct. People don't typically go to Seldovia to eat in restaurants, so the restaurants in Seldovia are not well mapped. And their metrics are geared toward time in the app, return users, things like that. And so all of this reinforcement causes literal different geographic spaces to be better mapped or better funded than others. And what this means is that if there are nonprofits or governments or less industrialized rural places that don't have those kind of endemic dollars, they won't be as well mapped. And so we don't know as much about them. And in general, it's possible to say that we don't know as much about Alaska, for example, not in the traditional kind of like Google mapping and OpenStreetMap mapping sense. There is a lot of science that happens here. So in some ways we know more. to put these things in contrast, and urban here can also stand for kind of Silicon Valley, and rural can stand for just distributed or people who are outside New York, San Francisco, Singapore, whatever your tech centers are. We have very different strengths between urban and rural ecosystems, and these should be our priors for how we think about the problems that are best for us to solve, right? So Silicon Valley really focuses on scale, having more users, having more dollars, having more of everything. And whenever decisions are made, they're always making decisions at that scale point, right? They're investing in New York. They're not investing in restaurants in Kotzebue or mapping restaurants in Kotzebue. In the rural context, we have many strengths. Like, we are very resilient and very good at reusing things, right? People say, why are there so many like broken down cars in Nikiski? And I say, because they're useful. You might need something off of one of those vehicles one day, right? So in the urban ecosystem, you would just buy a new car when something small breaks. It's really interesting to start contrasting these and thinking about what is it about subsistence and resilience that can enable us to think in a different way and to use smaller data or more distributed data or distributed sensing to solve problems in a way that's still effective, but doesn't depend on this like hyper density and scale of data in order to do that. Because that's the easy way to do it. The dollars always kind of follow the shortest path, right? They're always going to solve the scale problem first because it's easier. But here we just have different types of problems and different types of strengths. So if we go back to Project Drawdown and think about it in the context of something like climate change, there are a couple of different strategies at the top here. I think I sorted this by scenario one, so that drawdown point you saw, this is the combination of the strategies that they talk about. But we could say things like, what does it mean to like pursue onshore wind turbines as a strategy for improving electrification, bringing more electricity to market? Can we do more mapping of the viability of different sites for wind turbines? Can we develop better microgrids that integrate with those that are hyper-local and don't depend on aspects of scale? What does that look like? If we do these things, and they are happening in Alaska, and I think that's why this is interesting, they will become useful in other ecosystems. But we're just the test bed. We're like the tip of the icebergs, you know, literally, figuratively, where we're trying to figure out how to change things on the edge so that we can be more efficient. And that's kind of what efficiency is all about. How do you think about the problem on the edge as opposed to in the middle? So I'll leave it here, but I want to thank you for listening to a gross densification of several different mapping stories. There's a ton that happens in mapping. It's an incredibly like large discipline. There's a ton of technology. I'm happy to talk a little bit about the technology as well if you want to ask questions about that. Happy to talk about product management and kind of what that looks like in the Silicon Valley context and anything else here. Otherwise, thank you for listening.
Thank you so much, Claire. And we want to be respectful of your dinner time here as it's 8:07. So if you have to break away here, do let us know. But if everybody's got questions, please write them out in the chat and I'll go ahead and read them out, or Claire can read them as she wishes. I guess not seeing a specific question right now in the chat, I might kick us off and ask, back at the beginning, you mentioned how, Uber had spent $500 million developing their mapping, and, tying those two concepts together as the map being a combination of design and data, but the map also being a product, where where does that line reside for companies that need to build something, or versus buying what's already out there? Maybe just sort of leaving it with that. Why doesn't OpenStreetMap simply get done and then everybody uses it? Why does each company need to build their own map product?
Great question. So OpenStreetMap is a data source primarily. There are a lot of tools attached to it, but in order to run a ride-sharing company, for example, you need a lot of things on top of that in order to make it usable for your use case. So for example, I spoke about driver localization or figuring out where the driver is. In order to do that, typically you take the series of GPS points and you apply some sort of like Kalman filter, HMM model like was discussed, and try to determine whether it's on the map. That's not a function that OpenStreetMap has, because OpenStreetMap is more of a database and doesn't have those functions built in. However, OpenStreetMap has been around long enough and people have tried to build these different platforms long enough that there actually is a whole ecosystem of open source software around it that enables you to do that. So you actually can deploy an open source map match model and an open source router and host your map, like your cut of OpenStreetMap in your own ecosystem and build a ride-sharing product almost out of the box. You would need to build a client and all of the user-facing stuff, but in terms of the mapping platform, it's actually possible to knit things together. Lyft builds this internally because we have very special use cases and we want to tune them really specifically to what we're doing. And we bring in other types of data as well. And all of that contextualized and optimized together requires much tighter coupling and interactivity between all of those elements. And so we don't just use things out of the box. But when we started, we just used OSM and OSRM, which is the open source router. We just used those together. And that's what we were using to generate ETAs and started there.
Great. Question from Vanessa regarding battery performance in Kotzebue and how you dealt with actually powering the sensors.
Yeah, I actually so I was using a Raspberry Pi with a digital display for the Novelda sensor, and I had a battery pack that I'd wired to it. And I ended up keeping it inside my jacket most of the time. We'd pull it out when we were taking a reading, right? It wasn't as cold in March as it would have been in like January or December. I think it was in the 20s, so it wasn't as bad. But it's a very real problem. And there are a couple companies locally who focus on things like battery performance and like battery heating, which is definitely an interesting Arctic specific application.
For sure. Question from Solomon, who asks, what is the barrier to entry with contributing to open source mapping projects?
Barrier to entry. If you are interested in mapping, and Solomon, feel free to chime in if you want to ask more specifically, but if you're interested in mapping and like drawing roads or labeling buildings or, labeling a restaurant nearby that you know about because you live in that neighborhood, it's possible to edit OpenStreetMap. I would suggest doing some research and going through like the basic training that the open source community has put together so that when your edits are made, they keep them basically. But yeah, take a look at that. There's a couple different platforms where you can do mapping for humanitarian maps in particular. So places that have very incomplete maps often need a lot of help. Look up HOTOSM, HOTOSM, and that's a good place to start. And there's training materials there too.
Great. If we're able to hop back on the slide deck for a second, Valerie asks on the second to the last slide, what were the numbers on the right-hand side?
Oh, yeah, take a look at Project Drawdown as well. Here, I can share this. take a look at Project Drawdown website, and they have all of this stuff interactively. These are the CO2 drawdown scenario. So I believe this is, what is the scale on this? This is megatons, I believe, of CO2 over that time period, or perhaps annually. But it's a relative scale, like they're all scaled to the same thing. So if it's annual, this is how much CO2 is expected to be taken out of the atmosphere if we built all of the wind turbines that this particular scenario is forecasting that we would. This is more ambitious, right? So let me go back. Scenario 2, drawdown hits earlier, and so it's a more ambitious scenario and more definitively kind of bends the curve there, which is why you see bigger numbers. But this on the website will tell you how many turbines would have to be built and what kind of scale they're talking about to get to that point. It's a really great project, big, huge collaboration.
Awesome. And question coming from Dan on other data coming in besides GPS. Are there fleets that transmit, for example, temperatures as well as GPS data for mapping?
So I don't have a ton of direct knowledge about other types of fleets. I know that a lot of fleets are looking at monetizing their capture of various things. So if there's some trucking fleet that has temperature, ambient air temperature, whatever it is that they're measuring, they may be looking at monetizing it and selling it. It's a pretty common thing that's happening right now, and a lot of companies are trying to build their own fleets for collecting data. It really depends. Not sure if that answered the question.
I've got another one for you here, which is, in the sheer volume of data, are we seeing the size of these databases go up exponentially, as sensors get better and as more people sort of join these networks? And how is that managed?
Yeah, we're going to have a data storage problem. I think it's already true for a lot of companies in Silicon Valley, but there are interesting problems with like video, for example. So cameras get really good. You can do like 4K video on some little cheap camera. So you put that in the front of your, logistics fleet or whatever it is, and you bring all this data back. What do you do with it? Do you upload it? Do you have, you've kind of got an operational problem where you have the driver or whoever's operating the vehicles. Do they have to upload it? And if it's 4K, it's going to take a long time. Do you have the right internet connections? Do you do the logistics to get it back? And then once it's on the server, what are you going to do? Do you run machine learning and like computer vision across it and try to extract features of some kind and localize them? If you're doing that, you have to process really high res imagery. So I think a lot of the industry is starting to look at more processing on device or at the edge, and pre-processing that into the final form that the data is going to be used in, or something closer to it. And that can decrease like the storage requirements and can decrease the processing overhead and stuff like that.
Awesome.
I've got maybe a kind of a product type question.
Sure.
I'm wondering about just products where the map is the interface, like Lyft is maybe like this, and like Snapchat has portions of that. And I'm just wondering what you think about like the promise and the opportunity, and like whether we're going to see more products where the map is the interface.
I really hope so. I sincerely hope that we will see a lot more of that, because it's such an intuitive visualization of data. People are really good at orienting themselves on physical maps. I mean, sometimes you don't know which direction, but you can say, yes, this is approximately where I live, where I am. And I can see that somebody else is in Japan and somebody else is in New York. And something like a Facebook news feed it doesn't have relative, it doesn't have demarcations that help you orient yourself, right? So you don't know like whether you're on a timeline or whether you're scanning through the top things first or whatever it is. It's with the algorithmic orientation, it's very hard to know when you're done or orient yourself. So I think maps are appealing for that reason. I don't know if I can say much about consumer. I've been kind of on the platform and B2B side of this for so long that I'm not the person to ask about consumer whims, so to speak. But I think Snapchat is the one that everyone points to as like a really successful deployment of an OpenStreetMap like interface. Do you think, to shoot this back at you, Ben, do you think there are like interesting use cases or things that maps could be used for that they're not being used for?
I've read about, things that are happening like in China and Asia where they've like bundled a lot of, where we have like 6 different apps. Certain apps in China will be like 7 different things. And I think some of them are like a map interface where it's just everything's super spatial. So so I think a lot of people have had big ideas for that. And I think it is happening in other places. So I'm just curious to see where it goes.
Yeah. There have been many cases, including in rideshare, where Asian companies have done things that then like much later took hold in the kind of American equivalents or European equivalents in some cases.
Any other questions out there? Last chance, don't be shy.
You can find me on Twitter too.
Yeah, you had that up before. You're just at Clare Corthell, right?
Clare Corthell, yep.
Awesome. Well, without anything else, I will let you and Mark get off to your dinner, Claire. Thank you so much for doing
Cool.
this. It's been fantastic.
Thank you. Appreciate your time, everyone. And please do reach out to me. Hopefully we can do this in person sometime soon.
Absolutely, as soon as all this COVID stuff's over. And just FYI, people probably know from the newsletter, but there won't be a meetup next month. We're taking a break for the summer. So we'll be back in August with some DevOps from some fantastic folks at Google. Have a great night, everyone, and a great summer until we see you at the end of it.
Great. Thanks, Bradley.